Now, let us see what happens actually when this object or a ball, heavy iron ball or metal ball, is, let's say, is dropped. Then what are the forces acting on it? Let's say this is the object. Then definitely we know with the mass m, then mg is acting downward. Gravity, the center of the earth is pulling it with a gravitational force, and there is acceleration to gravity in times m, which is the force due to gravity, which is mg. But it is traversing through a medium. What is the medium here? It is air. And what happens when an object goes through a medium? Let us imagine this to be, this to be water. This is shown here. And if I push an object through the water, what happens? The water gets displaced, and it is trying. When I lift the object back up, it is trying to come back to that space. So, which means when we push through, there is always a resistance. Push through any medium, and when you push at an object, it always pushes back at you. We know that through Newton's third law of motion. So which means if I push through air also, there will be resistance. This object is falling through air. So when I push slowly, I mean with a lesser velocity, then there is lesser pushback on the ball, on the object. If I go down with more velocity, then I create more disturbance. I push more air, then more pushback I get, which means, let's say initially this object, this is the starting point. I throw it from here. This is t equals 0. Initially, the velocity is v. Then as time progresses, the velocity becomes bigger. Let's say v1, v2, and when it's at some point it becomes huge. I mean, it's v3. Let's say it's a bigger velocity. It keeps gaining velocity. That means it is moving through more air, which means there is a more pushback to it in terms of this reactive force. So this force is called the drag force. The drag force. This is Fmg and this is F drag.